Ever look at the world around you and wonder, how do you actually measure all this stuff? Well, in this explainer, we're going to decode the geometric world, from the simple flat shapes we see every day to more complex 3D objects. I'm going to show you a few core strategies that will unlock pretty much any geometric puzzle you can imagine.
Okay, so let's jump right in. The first big idea here is that tackling weird, complicated shapes isn't about memorizing dozens of different formulas. Nope, it all comes down to one single, really clever strategy.
I mean, think about it, right? The world isn't made of perfect squares and circles. The layout of your apartment, a piece of land, a component in a design, they're often these weird, irregular shapes. So when you're looking at something like this L shape on the screen, how do you even start to figure out its area? Well, the answer is this awesome little trick called decomposing. This is your secret weapon. All it means is taking a weird, complex shape and just breaking it down. You slice it into smaller, familiar shapes that you already know how to work with, like simple rectangles and triangles. And the method itself? It's as easy as 1, 2, 3. First, you just cut the shape into those simple pieces. Second, you find the area of each one of those little pieces individually. And then third, you just add them all back together to get the total. That's it. It's really that straightforward. So now that we have that master strategy in our back pocket, let's build out the rest of our foundational toolkit. We're going to start in the 2D world and really master the idea of area. These two formulas right here are the absolute bedrock. For a parallelogram, area is just base times height. But, and this is a classic trap you have to watch out for, the height has to be the straight, up and down, perpendicular line, not the slanted side. And a triangle? Well, it's just half of a parallelogram. But why is the triangle formula 1/2 base times height? It's not just some random rule you have to memorize. There's a really beautiful, simple logic to it. A triangle is literally, physically, exactly half of a rectangle. And this slide just makes it click, doesn't it? On the left, you've got the rectangle, the whole space, which is base times height. And on the right, the triangle is just exactly half of that space. Once you see it like this, the formula A equals 1/2 B times H isn't something you just remember. It's something you actually get. Okay, so what about a trapezoid? It's got those two different bases, top and bottom, and the formula can look a little intimidating. But the strategy behind it is super simple. All you do is find the average of the two bases, add them up and divide by 2, and then you just multiply that average by the height. It turns a kind of clunky formula into a really simple process. All right, so we have a really solid handle on flat 2D space. Now for the fun part, let's take the leap into the third dimension. We're going from area to volume. And believe it or not, the tools we just learned are the absolute key to unlocking it. And here's the best part. You don't need to learn a ton of new, complicated formulas. In fact, there's one simple, super elegant formula that unlocks most of the volume problems you're ever going to see. And it's this. Volume equals B times H. Now, the crucial thing here, the whole secret, is understanding that big B. This isn't the same little b we used for the length of a base. No, this big B stands for the area of the base. Think of it like the entire 2D floor plan of the 3D object, which is something we already know how to calculate. Let's make this perfectly clear. Let's say you've got a box, and you figure out that the area of its bottom floor is 20 square units. Well, that means your big B in the volume formula is just 20. You've already done the hard part. The volume is just that area, that footprint, stacked up to a certain height. And this connects directly to something you probably learned years ago. We all learned that a box's volume is length times width times height. But take a closer look. What is length times width? It's the area of the rectangular base. So L times W times H is really just a specific version of our much more powerful and versatile formula, V equals B times H. So we've gathered our formulas, we've got our strategies. Now, let's shift our mindset a little. We're going to stop thinking like we're just memorizing rules from a textbook and start thinking like detectives solving a puzzle. These formulas, these are our clues. And every good detective has a process, a golden rule. For geometry, that non-negotiable first step is this. You have to write the full equation down before you start plugging in numbers and trying to solve. This is how you organize your clues and keep yourself from getting lost in the details. All right, detective, here's your first case. We've got a triangle. We know its total area is 12, and we know its base is 6. The piece of the puzzle we're missing is the height. So how do we find it? We follow the process. Step 1. Write the equation. We grab our area formula for a triangle and plug in what we know. So 12 goes in for the area, and 6 goes in for the base. Step 2, simplify the clues. We can do the math for 1/2 of 6, which is just 3. Now our equation looks way simpler. 12 equals 3h. And finally, step 3, solve the mystery. Divide both sides by 3, and boom, the missing height is revealed. H equals 4. Case closed. So let's just take a second and look at the powerful geometry toolkit you just built. You now have the master strategy to break down any weird shape you see. You've got the core formulas for 2D area down cold. You get how to use the big B to build your way up into 3D volume. And you know how to work backwards like a detective to find any missing clue. You have the skills. You have the strategies. So take a look at this new shape on the screen. If you look closely, you can see it's just a rectangle with a triangle on top. 2 shapes you have now completely mastered. Using everything we just went over, the question is no longer, can you solve it? It's, what puzzle are you going to solve next?